Welcome back to Project Pools. In the previous lesson, we implemented the LLCR. In this lesson, we will add another core lender protection feature, a debt service reserve letter of credit, also referred to as DSR-LC. Conceptually, a DSR-LC is a liquidity backstop that helps the lender still receive scheduled debt service even if CFETs are temporarily too low. So even if the DSCR drops below 1.0 in a period, the project can bridge that gap through the LC. Let's make this real with a stress test. We will take case 2 and apply a downside assumption. We reduce BESS availability from 97 to 78%. Then watch what happens. The DSCR sits slightly below 1.0. But with the DSR-LC in place, the model can still show that debt service gets paid on time, period by period. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the model start file for free and build the model alongside me. Link is in the video description below. Before we model the mechanics, let's quickly cover the theory of a DSR-LC, because this is a structure you will see frequently in real lender term sheets. When we talk about the purpose of a DSR-LC, we are really talking about liquidity protection, not credit enhancement. The DSR-LC exists to ensure that scheduled debt service can still be paid in periods where operating cash flow is temporarily insufficient. In other words, it bridges short-term CFETs volatility without triggering a payment default. From a lender's perspective, this is critical. Even if the DSCR drops below 1.0 in a single period, the LC allows debt service to be met on time and in full, preserving payment discipline and avoiding technical defaults. And from a structural standpoint, a DSR-LC is a standby letter of credit issued by a bank, typically in favor of the term loan lenders. It's usually sized to a fixed number of months of forward debt service. For example, 6 or 12 months, and it can only be drawn if scheduled debt service cannot be met from project cash flows. Importantly, this is not free liquidity. The project pays commitment fees on the undrawn amount and interest plus an LC margin on any drawn balance. Any amounts drawn must later be reimbursed from future project cash flows. In a project finance context, the DSR-LC is often used as an alternative to a funded debt service reserve account. The key advantage is that it avoids trapping cash up front, which is especially valuable for capital-intensive projects like BESS. The trade-off is ongoing commitment fees and interest payments if drawn. Before we build anything, let's look at our inputs from the information memorandum. We are given the LC size in months, the LC margin on drawn amounts, the commitment fee on undrawn, and an upfront fee. These assumptions drive both the availability of the cash flow backstop and its cost to the project. And now let's move back to the checkpoint file from our previous lesson. The debt service reserve letter of credit is the last section of our senior debt section, and since the DSR-LC only kicks in when our project has financial struggles, we will look at a stress case to actually see all of our formulas in action. So what we'll do is we'll take case 1, take the debt repayment profile of case 1 in our inputs time dependent sheet, grab all of these repayments here, copy this and paste it special as values only for case 2, which is our equity base case. Then let's turn on case 2, which is essentially the same case as case 1, except that our debt sizing will be turned off. And to stress case 2, we will assume a availability of 78%, which means that when we go to our operations sheet and scroll up to our DSCR, we are actually slightly below 1.0, which means that in all of these periods here, we can only meet 98% of our total debt service due. And this is the reason why I want to reduce availability for this case so that you can actually see how all of these formulas here would work in action. And we have quite some work ahead of us. And the very first thing we will actually do is pull in our total debt service, excluding any sensitivities. And we will pull in that debt service to ultimately determine our minimum DSR LC size. And our LC size will be the forward-looking debt service for the next 6 months. And we'll take the maximum thereof. So we will look at the maximum forward-looking debt service, which will then determine our DSR LC size. And to do this, we first have to pull in our debt service. So let's go in row 625, and that is going to equal to, let's scroll up to our debt section, and we have our principal in row 555. And let's actually flip the sign for this one. So this is going to equal to minus K 555. Let's anchor this hit F41 2 times. So that covers out the principal. And then we also have interest payments due. So plus our interest excluding base rate sensitivity. So select 572, hit F41 2 times and enter. Let's drag this one over, Control R. And that gives us the debt service due in each respective period before any sensitivities. And we do not consider any sensitivity here because at financial close, our lender issues us one letter of credit with a predetermined amount. And if rates then go up or down, that will not change the amount that is written on our DSR LC. And that is the reason why we do not include any sensitivities here. It's also noteworthy that we are not going to include any DSR LC interest down here, because if we include DSR LC interest for sizing purposes, what will actually happen is that if we sensitize different inputs, that might affect our total DSR LC interest if the DSR LC is drawn, and that would therefore then even affect our sizing. That's why for sizing purposes, we also exclude the DSR LC interest in this row. Then we can move on to model our periodic minimum DSR LC size in each period. And that is equal to, open parentheses, let's take our 6 months forward-looking debt service target size, hit F4 once. And we are in a yearly model, so we take 6 months and divide it by months per year. So months year, which is a named range with a value of 12 that sits in our technical inputs. Close parentheses. And let's multiply this with. Now watch out, if we are in the year 2025, we want to multiply this with the forward-looking debt service in the next period. So multiply it with L625, hit enter and drag it over, Control R. And you will notice that our forward-looking debt service is at its maximum in year 2035. And most typically, the DSR LC will be sized in such a way that we look at the maximum of the forward-looking debt service throughout the full financing tenor. So here for the DSR LC size, we take the maximum of all of these forward-looking debt services. Because we will not, at the end of each period, return our letter of credit to the issuing bank and then ask for a new letter with the new amount. That is very uncommon. And instead, lenders just insist on the maximum forward-looking debt service at initial financial close. So once we have the initial size, we can actually model our upfront fee, and the sponsor or the project SPV also has to pay 1.5% upfront or arrangement fee on that letter of credit. So here, similar to our term loan, we take our 1% upfront fee, fully anchor this with F4, Then we will multiply this with our minimum DSR LC size, which is in H626. So that's our final size, hit for once. And we will multiply this with our financial close flag at the very top of the sheet in row 11. Hit a for 1 2 times, hit enter. Let's drag this one over, Control R. You will see that we're supposed to pay $124,000 of upfront fee for that letter of credit. All right, then let's actually scroll up, and you might recall from a previous lesson that we should still have a yellow highlighted row for our upfront fee on our DSR LC. So we are ready to link this one in now. That is equal to, let's scroll down, row 628. It's a simple linkage. Drag this one over, Control R. Mark out of these cells, and let's get rid of the fill. And now these upfront fees are both considered in our total financing fees and in our total CapEx plus financing fees section, which then later on has implications on our depreciation and amortization of financing fees. So that now also sits in our non-cash amortization of deferred financing fees account, which is then reflected in the balance sheet and income statement as well. All right, let's scroll back down. And then next up, we will model our actual debt service, including our sensitivity and also including our DSR LC interest. So this is very similar to the number that we have determined right here in 625, except that we now include sensitivities on the interest rates as well as DSR LC interest. So let's actually pick up this value here, hit Control C and Control V, hit F2, and we still refer to our principal repayment in 555, but for the interest, let's refer to our interest including base rate sensitivity. And then we will also add plus, let's scroll down, our actual interest paid on our DSR LC, which is a hard-coded value from our copy and paste macro again. So pick up row 664, which we'll model at the end of this lesson. Hit F4 2 times and enter. Then we can drag this one over, Control R. Then next up, we will model 2 flags. The first flag to determine whether any debt is still outstanding, and if so, if our DSR LC is drawn in that specific period. Let's start with our first flag, whether our debt is still outstanding, and we will do this with an if statement equals if. And let's do a round function. And we will round, let's move up to our term loan account. We will round our balance brought forward, comma, to 2 digits. And if this value here is greater than 0, then we want a 1, otherwise a 0. Drag this over, Control R. And you see that our debt is outstanding for 15 years and fully repaid after 2040. And then for our DSR LC drawn flag, this is going to be an if statement again, if, and we will model a DSR LC balance or account further down here. And we will say if our balance carried forward in row 648 is greater than 0, then we want our flag to be turned on, otherwise 0. Close it and drag it over, Control R. Obviously, we haven't modeled that section yet, which means the flag is not yet showing up. But once we have implemented that, it should show up. And once we have the flags, we can move on to our DSR LC drawdown due to cash flow shortfall section. So here we determine whether we have an actual cash shortfall, and if so, how much cash would be available to draw from our LC. The first thing we'll pick up is our cash account brought forward. So that's how much cash is sitting in our SPV at the beginning of this period. And we'll get that value from our integrated financial statements. So let's move to our cash flow statement here. And that sits in our cash account in row 95, which actually turns negative. So obviously we don't want that, and that is actually a big issue. And once we have our DSR LC implemented, we hope that this cash balance should never turn negative. So pick up row 95. Then in that period, we will also have our CFETs available for repayment. So let's pull in our CFETs, scroll up, and we could pick them up here in 612. Let's actually just do that. Here we have our CFETs during our debt term, so we can just pick them up right here. So let's drag both of these over, Control R. And then we can model our release due to cash flow shortfall. And that is going to be an if statement again. So if the sum of our cash brought forward and our CFETs is smaller than our actual debt service in row 630. So this one actually includes our sensitivity as well as our DSR LC interest. So it's important that we pick up 630 and not 625. 625 is only for sizing purposes. So if that's true, if we do not have sufficient cash, then, we take our actual debt service and subtract whatever we have available as cash, which is the sum of our cash account brought forward and CFETs in that period. And if this is not the case, if there's no cash shortfall, then we want a 0 and close parentheses. And lastly, we'll multiply it with our debt outstanding flag in row 633. Hit enter and drag this over, Control R. So actually undo this, Control Z, copy this, paste special formulas, Alt HVSF, enter. So we keep our formatting. So for each single period, we now know how much money we are short. So that's good to know, but we also need to know how much actual release is possible. Now obviously we only have 8.24 million available, so we cannot draw indefinitely. And then this is going to equal to the minimum of our release due to cash flow shortfall required, and then the second number is our DSR LC size in H626, hit F4, minus, and now we look at our DSR LC balance, which we haven't modeled yet, and we'll pick up our balance brought forward. So whatever has already been drawn will be reflected in our balance brought forward, and that is the amount that has already been drawn at the beginning of the period. So we basically just subtract what has already been drawn from our initial size, and that will give us our actual release possible. Close parentheses, drag this one over, Control R. So all these numbers don't yet fully make sense because we haven't modeled the LC all the way. And in the next row, we will continue with our DSR LC commitment available. And the commitment available is a very similar formula. So it's open parentheses. We take our initial LC size, fully anchored with F4, and then we subtract our balance brought forward again in 645, which is what we just did in this formula, close parentheses, and let's also multiply this with our flag. Hit F4 2 times and drag it over. So right now our balance has not been drawn, so we would have available the full DSR LC in each period until we actually model our account down here. So let's just do that. And as always, our account is set up that for the balance brought forward, we refer to the previous period's balance carried forward. This is the sum of the above. And then let's model the drawdown due to cash flow shortfall. Let's think about this. We will use an if statement again. And if our balance brought forward in the same period is smaller than our initial DSR-LC size, hit F4 once, then we would still have something available to draw down. So which means that then we want to draw down the minimum of our actual release possible. So this is how much the SPV would need to cover any debt service payment shortfalls. But then we also have to look at how much LC is still available. So we again take the DSR-LC initial size and subtract the big balance brought forward from that. That's how much would actually be available. Close parentheses. And if our balance brought forward is not smaller than our DSR-LC size, then we're maxed out. In that case, we wouldn't want a zero drawdown because there's no LC available anymore. Hit enter, drag this one over, Control R. And we can see that we are now actually drawing down $4.7 million, which equals our actual cash shortfall over a period of 13 years. But what would still be missing is our actual repayment from cash flows. And what's also missing is the actual fees that we have to pay on our letter of credit. So let's start by actually modeling our repayment, which means that if our LC issuing bank pays us $4.7 million, eventually, once we have cash available, we will have to return those $4.7 million. And this is what this row is about. So this is going to equal to the minimum of either 0 or minus, because we want a repayment to be modeled in this account, the minimum of our balance brought forward, if the cash flow is sufficient to repay that. And if not, we will model in 653 our total cash available for our DSR-LC repayment. So either we are able to fully repay, but we will check how much cash is actually available down here. Close parentheses twice, and let's drag this one over, Control R. Now we're actually repaying in each period after a drawdown has occurred. However, obviously we now have to model this section to see how much cash is actually available to repay our DSR-LC. And for that purpose, we will pull in two different numbers from our cash flow statement. And the first one is the cash available for DSR-LC repayment. And that is a separate row in our cash flow statement, which comes right after our senior debt section, where after the total debt service has been determined, we model our cash flow available for DSR-LC, and you will see the cash flow for our LC is actually negative in the first periods. So let's pick up this one. And we will also pick up the cash account brought forward, so the cash that sits in the SPV at the beginning of the period. So if we have any cash in our account, we can use that one as well. But unfortunately, there's none. So let's link this one. And the total is basically just the sum of these two. Drag this one over, Control R. Hit Control Z, let's undo this. Copy all of this, drag it over and hit Alt H VSF. Enter. So we keep our formatting. And you can see in row 647 now that our repayment kicks in 2038. Which is the first year where we have sufficient cash flows available to repay our debt. So we would expect our DSCR to be above 1, and that's the case. And everything that's above 1 will be used to repay our LC, which will then be fully repaid in year 2040, after which the equity investor could receive its first dividend. You will notice here that the total cash available for the DSR-LC repayment is artificially extremely high because we keep pulling in a very high cash account brought forward, because right now we haven't modeled our equity section yet, so we do not distribute any dividends and instead just accumulate a bunch of cash in our cash account, which sits there indefinitely. But in our upcoming lessons, we will actually model our equity section, which will then consider a dividend or distribution. Then let's move back to the operations sheet and actually finish our DSR-LC. So we have implemented the full mechanics to ensure that we can cover any cash shortfalls up to the DSR-LC size. What we haven't modeled yet is what the SPV will have to pay for this safety net. And that is in this section down here. And similar to our term loan, we have to pay an interest on drawn amounts, and we also have to pay commitment fees on undrawn amounts. So if our DSR-LC is actually not drawn, all we have to pay is a commitment fee of 0.7% per year. If it's drawn, we actually have to pay both a margin of 2% plus our base rate, which is SOFR. So let's first pull in our margin, and that equals to, scroll up, our debt outstanding flag times our 2% margin in G656, hit F4 once. And for our base rate, let's pull in our SOFR from our inputs time dependent sheet again. And let's open parentheses, use an X lookup, or equals open parentheses X lookup. Our lookup value is going to be our year, hit F4 2 times. The lookup array is going to be in our inputs time dependent sheet. Scroll up all the way to our SOFR curve. The years are given in row 11, so select all of these guys here, hit F4 once, and the return value is going to be our applied SOFR forward curve in row 13. So select all of these guys here, hit F4, then we want this to be 0 if not found, and we want an exact match, so another 0, close parentheses. Then let's move back to our operations sheet. And actually, instead of selecting row 13 here, let's adjust this to row 12, which was our SOFR curve before any sensitivity. And we will add with a plus our sensitivity right here. We can also get rid of the operations reference here, hit F4 once. So our sensitivity for our base rate is considered right here instead, close parentheses, and we'll multiply this with our debt outstanding flag. Get rid of this reference here and hit F4 2 times. Enter. And then our all-in rate on the drawn LC is the sum of those two. Let's drag this over, Control R. And you can see that we get a 5.5% total all-in rate on our drawn LC, which means we will be able to calculate our interest for the drawn LC down here. But let's first model our commitment fee that we have to pay either way. Either way meaning that is the minimum fee that we will have to pay in case the amount is undrawn. So let's pick up the 70 bips or 0.7%, hit F4 once, and then we will multiply this with our DSR-LC commitment available in row 642, and that is essentially the undrawn amount. So we pay commitment fees obviously only on the undrawn amount. Hit F4 1, 2 times, drag it over, Control R. So we basically pay $670,000 in commitment fees over the full financing tenor, but then we'll also have to pay an interest on the drawn DSR-LC, which will be much more expensive. And that is going to equal to our balance brought forward, so our DSR-LC that has been drawn at the beginning of the period. Hit F4 1, 2 times our all-in interest rate on the drawn DSR-LC. Hit F4 1, 2 times as well. Drag this one over, Control R. And now we know the total interest on the drawn amount, which is $1.7 million, which means that we can now take the sum of these two cells, drag it over, Control R, which will actually undo this, Control Z, copy this, Alt H V S F. And that will tell us that we have to pay $2.4 million in total LC commitment fees and interest during the full financing tenor. And again, this would cause a circularity because the DSR LC interest is tax deductible, which affects CFETs, which then affects term loan size. And the term loan size affects our DSR LC size again, which means we implement a copy and paste macro. So what the macro will do is take this row here and then paste special values only, Alt HVSV, until that circularity has been broken. And we will automate that process by just simply hitting our master macro. So all of this has already been sufficiently implemented so that all circularities within the modeler are automatically solved. And if you would like to see how that works, we can hit Alt F11. And here you can see that we have a copy and paste macro for our target debt service, our cash sweep, and now also our DSR LC interest. So we take our delta and copy and paste the values so long until our DSR LC delta is 0. Our DSR LC delta sits right here. That's the difference between those two row totals. And we named this range here as DSR-LC copy and this range here as DSR-LC paste. Great guys, that means that we have now completed our senior debt section, which was a quite lengthy exercise. But now we are completely done with our senior debt section, which you can also observe in our 3 statements. So within the cash flow statement, you will see right after our operating cash flow, our senior debt section under financing cash flows. So here we now have term loan interest, DSR LC interest, term loan principal, as well as the cash sweep. And if we turn our case 2 back to normal, where we delete our availability reduction, execute our master macro and move back to the sheet, you will see that our DSR-LC interest will now only reflect our commitment fee payable during the 15 years financing tenor, which is a constant and in line with the outputs here. So you can see then we would only have commitment fees payable. And since the DSR-LC amount wouldn't change over time, we would just pay a fixed 70 bips on that amount for a period of 15 years. We have also modeled our cash sweep in a previous lesson. So I believe that was case 21. So if you switch over case 21 and hit our master macro, you will see that our cash sweep actually ensures a repayment earlier once it kicks in after 5 years. And you can see that our DSR-LC actually adjusts its tenor as well, because we have implemented a flexible flag considering the debt outstanding. So if there's no debt outstanding, our DSR LC won't need to be issued anymore. So here's an automatic adjustment of the financing tenor. And right after the senior debt section here, we now have our DSR LC mechanics implemented, which kick in case of an extreme cash flow shortfall. Great, and the only thing that is now still missing and still causing our balance sheet to not balance is our equity section. And this is something we will cover in the next lesson, where we will wrap up our core modeling sessions, implement our share capital account, determine our free cash flow to equity, and then ultimately determine key sponsor or equity KPIs such as our levered equity IRR, the net present value to the sponsor, cash on cash yield, and the payback period to equity. All right, guys, this was it for this lesson, and I will see you in the next lesson. See you there.